Okay, good afternoon. Today we are going to discuss about our second chapter, that is large scale systems and the architecture for integrating systems. Previously, we looked at in the chapter number 1, we discussed some of the basic elements and the concept in integrating systems. So in this today's lecture, we will start the chapter number 2, and our focus is on large scale system and architecture for integrating systems. So in this today's session, we are going to focus what is a large scale system, and then we will discuss about distributed systems and some of the features or characteristic of these distributed systems. And in the remaining lectures, we will focus the grid computing, web services and web service model. How do web services work? Service-oriented architecture, middleware concept, web services components, and some of the web services component like XML, SOAP, WSDL, and UDDI. So these are some of the web service components we will discuss in detail. Okay. First, let me begin with this large scale system. Before I dive into this large scale system, let me give you some brief idea about this large scale system. So the term itself has the meaning large scale system, large in size systems. So previously you might studied various kind of enterprise level systems. Can you please tell some of the enterprise level systems? Enterprise level systems. Hello? Some of the enterprise-wide or enterprise level systems.
Knowledge management system.
Knowledge management systems.
Supply chain management system.
Supply chain management system.
ERP.
ERP. ERP. What else?
Customer relationship management system.
Customer relationship management system. Okay. In your previous subject, we discussed 4 major systems that drive what? 4 major systems that drive digital form. 4 major enterprise level systems that drive digital form. So we looked at enterprise level system like ERP systems and customer relationship management system, supply chain management system, and knowledge management system. So these are the 4 major systems that are driving the enterprise digital forms. Okay, so with that brief idea, you see today the web, the World Wide Web, it was designed, and most of the business organizations are using this web to run their business operations. So the web is providing the platform in which companies and business enterprises, they are using it as the computing platform to connect, to integrate, to share, and to access various kind of data informations. Basically, this web is providing the computing platform, the connectivity platform to integrate systems, various systems. So when we come to this various systems mean, so you see now the enterprise level requirements are growing, like businesses are getting bigger, and business enterprises are running their business operation not only in the local market, but also they are expanding their business operation to other global marketplaces. And they have huge number of customers. They have a huge number of collaboration with the suppliers, and they have a global suppliers. They have a global customers. They have a global business providers, service providers, vendors, and their operation is business operation is huge, and they are dealing with this huge amount of data, big data, and they need to manage their business operation. They need a sophisticated systems. Those system can be in one place, or it can be in multiple places or multiple locations, and they have a requirement to connect their subsystem with the main system, or they have a dedicated autonomous system in various geographical locations, and those system has to be connected with other system, and they need a platform, or they need a platform to share their data and information without any barriers and without any delays. So nowadays, the business requirement for this computing platforms are getting much more bigger, and there is a huge growth in this business operations. And when we come to this business operation, I mean this enterprise of business operation, most of the business organizations are running this electronic businesses. So then they have a special requirement, like they have to run their servers for continuously, and they have a global customers and global suppliers, and they have to provide these customer services, and continuously they have to give their services. So their servers and computers and their network and their system should be work all the time, and then they need a what do you call this, a requirement. I mean their system should be alive for 24 hours all the days. And also nowadays the business organization, they are willing to integrate separate distributed resources, like they have a server, they have web services, they have data and informations in the various nodes and databases and servers, and they want to integrate all these distributed separate and distributed resources with their systems, and to take advantage of supplier offers and to deliver customer requests, like they want to time to time they want to communicate with their suppliers, and they want to give the reply or responses to their customers' queries. So it shows that they have the business requirement. They have a huge business requirement in this growing business society to customize for special situations. So they need a system to customize for the special situations, to manage the special situation like a seasonal demand or a festival offers, or to find a niche market, or to find the target customers, or to provide any special offers. So for these special kind of situations, they want to customize it, like analyze a huge volume of data. So finding a niche market, so they have and using various kind of modeling, simulations, and analytics. So they want to customize their system for some special situation or special scenarios, to interact without having to exchange detailed information about their interfaces, to interact with their system, without having to exchange detailed information about their interfaces. Like they have systems and various autonomous systems in various locations, and they have a capacity, they have access privileges, like their resources can be accessed from various locations, and employees who are connected, or the partners who are connected with their system, can look at or can access their data and information. And now for the security's point of view, the companies are willing to access I mean the connectivity or interaction with their system without exchanging or without accessing the detailed information about their system interfaces. So they have a special requirement. In a sense, they have a special security requirement. So these all are possible. These all business requirement and the growing business field. These all are possible by creating or developing a large scale systems, large scale enterprise-wide systems. So enterprise application with the help of integrations, autonomous business process adaptations, and e-commerce site integrations are still difficult, and it has various kind of requirements. Okay, now let's come to this large scale systems. Large scale system is one that support multiple simultaneous users who access the core functionality through some kind of network. Large scale system means it support multiple simultaneous users who access the core functionality through some kind of network. Most emerging distributed applications are very large, that are demanding large amount of storage in data resources. So for example, e-commerce systems like Amazon, eBay, and Alibaba, and some of the large scale e-commerce system. And online businesses, large scale online businesses. And social network site like Twitter, Facebook, and WhatsApp. So these are some of the social networking sites. And some of the search engines like what you call Google, and some of the scientific or some of the research institution network like NASA. So these enterprises and these companies has the large scale enterprise system. So they have a huge amount of data, and also they have a huge storage capacity, and they are providing the support for multiple and simultaneous users access. In a sense, they are providing the connectivity through any kind of a network mode, and their users can get the access simultaneously, and multiple users can connect at a time, and they can access the data and information from their systems. So large scale system, large scale enterprise-wide systems. So these large scale systems can be in a architectural view. It can be in different architectural views. Like the first one is distributed system. The first one is distributed system. Before we discuss about this distributed system, any problem in this large scale system? Hello? Anything do you want to clarify? Any doubt? Hello? Hello? Are you there?
Yes, sir. Yes, sir.
Am I audible?
Yes, sir. Yes, sir.
Okay.
Yes, sir.
So any problem from this large scale system?
No, sir.
Shall we move into this next slide?
Okay, sir.
Okay, sir.
Yeah, tell me.
Sir, are
Yeah.
facing public loop. So they
Sorry?
are telling they can't network issue.
Sorry?
some students are facing network issues, sir. So they are telling they can't add to the link, sir. Again, lecture. While if once cut, they can't add it to the lecture, sir.
Why can't they try again?
I think they are trying, sir.
So ask them to try.
Okay, sir.
Waiting. There is a waiting room. So that's why I think.
So I'm admitting all the students. Those who are connected, I'm admitting all the students. So there is no students in the waiting list. There is no student in the waiting list. Okay. If anyone is facing a problem, please ask him or her to reconnect it. And if the person is in the waiting list, I'll admit him. Okay, let me move into this as next slide. That is a distributed system. Okay. Now you know this the requirement of a large scale and how the business enterprises are looking for a system to run their business operations. And now we will discuss about distributed systems. So now you know distributed systems mean business enterprises. They have a business operation in the global marketplaces, and they have established their enterprises or their offices or their companies in different locations, different part of the world. So to easily handle their business operations, or to easily handle their manufacturing process, or to easily handle their customers' queries and what with these customer queries, or to easily handle their manufacturing plant, they have various physical locations. Physically, they have established their business enterprises in a separate, what you call this, geographically distributed office or company setup they have created. So their enterprises are connected. So they have a separate company network, and they have invested huge amount of money for their infrastructure. In a sense, they have bought huge amount of servers and computers and network equipments, and they have a huge amount of what you call this IT staff. So, and this IT infrastructure from various locations should be integrated for the smooth functioning of their business operations. So then they can easily transfer their data and informations, and the headquarters, from the headquarters, the other connected regional office or branch offices can access the required data informations without any delay. And so then they can carry out their transaction and business operation very smoothly. So distributed system is a network of autonomous computers cooperating to accomplish a task. A distributed system is a network of autonomous computers cooperating to accomplish a task. A distributed system is a one in which components located at network computers communicate and coordinate their actions by passing the messages. Hardware and software component of a distributed system coordinate their activity by sharing resources such as data, computations, compute cycles, bandwidth, and storage. So from the previous scenario, you can understand the huge enterprises, large scale business enterprises. They have various branch offices, regional offices, headquarters, and they have a business operation not only in the local market, they have a business operation from the global marketplaces. They have established their offices and this what do you call this, companies all over the world, and these companies network or office network should be connected or integrated with the main headquarters, so then they can easily access their data informations. So the distributor, now their system is not in one place, it is distributed. So, or we may say that they have a system, their systems are distributed, geographically distributed, not in the single place, but those are in different locations or different uh, uh, part of the world. So distributed system. Sometimes they have a branch office in one country, headquarters in another country, and a regional office in another country. They may have a data center in another country. They may keep the backup data center in another country or another continent. So various locations, in various locations, they are having their systems. And these systems should be integrated and interconnected for the smooth data access. So what sort of data or what sort of resources they are sharing? So they are sharing their hardware and software components of a distributed system, coordinate their activity by sharing resources, such as they may share and they may access the data. They may share the computations, like some sort of calculations, computation sense. Let's say from the huge amount of customer transaction data, they are going to get a summary report. So computation, so huge volume of data. From that huge volume of data, they want to process it, they want to calculate it, and they want to find the target, what do you call this, customer group or target transactions. So the computation. So to process this huge volume of data, they need a much capacity of computing power, computations, and the computing cycles. So in an interval, timely interval, they want to calculate it. They want to get the summary report. So computing cycles and the bandwidth. In a sense, they have a connectivity, and this the connectivity for the data transfer and the bandwidth. This bandwidth should be shared among and between these components, like to transfer the data from one location to another locations. The connectivity, the bandwidth should be higher, so they can get that, they can share that bandwidth also. And storage, to store this huge volume of data, so they may use servers or databases or some other backup components. They are having the storage capacity. So this storage capacity can be shared with other connected components to store the data and informations. So this storage also can be shared among the connected components. So in the distributed systems, there are various components. Those components are located in various autonomous places, and these components can be communicated and coordinated. And these among these components, they can share some resources like data and computations and compute cycles, bandwidth in the storage. So we call them in a single umbrella term. This system is called distributed system. What the idea? Hello?
Yes, sir.
Okay. A distributed system is a collection of loosely coupled processors interconnected by a communication network. So a distributed system is a collection of loosely coupled processors interconnected by a communication network. Large-scale distributed systems are typically characterized by huge amount of data, lot of concurrent users, scalability requirements, and throughput requirements such as latency, etc. So when we take these large scale distributed systems, it has some sort of characteristics such as it is dealing with huge amount of data and a lot of concurrent users like from various locations, from various components, locations. The users are continuously accessing the data, a lot of concurrent data access. Many users are accessing the data from the centralized server or centralized systems. Scalability requirement, like the system should be scalable in a sense. If they are establishing another office or another, if they are moving into another market, if they want to establish a company or any part of the headquarter, sorry, this branch office, their system, existing system should be scalable. I mean, for the newly established branch office, they must create a network environment or a component, and those newly created component or a network should be connected, and the existing distributed system should support or can be adaptable or should provide services to a link with a existing, with a newly created system. So scalable requirement and throughput requirement. As I mentioned earlier, throughput means the bandwidth. So in the bandwidth requirement, so when there is a huge amount of data access and the connected bandwidth should be provided for the demandful regions or demandful network components, so then they can access their data. And latency, so there should not be any delay or late in the data access or data retrieval. Typically, the nodes run software to create an application or a service. So, for example, when you take this Google, what do you call this search engine, there are thousands of Google nodes. I mean, Google computers are working together to build a search engine. So you might have seen this Google search engine. They have a data center or data farm, server farm, and in which they have located huge number of servers, and they have a different categories of servers, and these servers have what you call this huge capacity of storage capacity, and a huge volume of data can be stored into these servers, and these servers can provide services. I mean, the data accessibility to other connected thousands of connected computer nodes. So this is one example for the distributed system, like Google search engine. So Google has the server farm in various continents, like they may have the server farm in Europe and Asia and America and some other developed countries. They may have server farm as well as data center, as well as they have the backup server farm also. So they are keeping the backup servers and backup data centers. So then they cannot lose any piece of data if there is any natural disaster, or if there is any natural disaster or any kind of damage. So they cannot lose their data. So they are keeping the backup server farm also. So here you see, here are some of the popular enterprises and enterprises. They have a large scale distributed system. Some of the enterprises you might seen, like Amazon, they may have a large scale distributed system, and Facebook, you might seen they may have this large scale systems, and Yahoo, Twitter, Netflix, and these are some of the popular organizations. Their systems are large in size, large scale distributed system, and inside this this plot, you may find some of the technologies like Hadoop, Spark, and Alibaba Cloud, and Redis, and AWS, Microsoft Azure. So these are some of the distributed environment technologies or technologies. They are providing the distributed architectures. Any problem? Any doubt? Anything do you want to clarify? Hello? Hello?
Yes, sir.
Any problem? Shall I move into next slide?
Okay, sir.
Okay, great. So now we are going to distinguish the characteristic between centralized and distributed systems. So what are the characteristics between centralized systems and the distributed system? So if it is a small in size or mid in size enterprise, they may keep their system as a centralized system. If it is a large scale enterprise-wide systems or enterprises, they must have distributed system because they have data centers. They have a network or components in various locations, various geographical locations. So they have a distributed systems. So the characteristics for if it is a centralized systems, one component with non-autonomous parts. So if it is a centralized, maybe they have only one component. Components mean one computing architecture. There they have the servers and some other connected network devices and databases, and everything is located in one central place. They have a system in one central place, centralized system. If it is a distributed system, multiple autonomous components in a sense. So they have a geographically distributed centers. In each center or each location, they have a separate networked offices or network system. So it should be connected. Since it is a distributed, geographically distributed environment, it has multiple autonomous components. Because they have a multiple distributed, geographically distributed office setup or network environment. So multiple autonomous component in this distributed system. The centralized component shared by users all the time. Component shared by users all the time. So for a small office environment or a mid-range of enterprise, this components mean the IT architecture, like the servers, database, and network connected devices, all can be referred as a component, like web services and everything. This component shared by users all the time. So this particular component, like the database, the servers, the bandwidth, and the network devices, and these web services, all can be referred as a component. Component shared by users all the time. All the connected users inside the organization or enterprise, they are sharing this component. They can share the data, or they can access the data from these servers. They can access the data from the database. So they can share the data. So components shared by users all the time. But in case of distributed environment, components are not shared by all users. Components are not shared by all users. So they have a system in various geographical locations. So the users, those who are connected with this particular component only, they can access the data and information. So the people, the users, those who are connected with this particular component only, they can access the data. In the centralized system, all resources accessible. So since it is a centralized system, all the data, information, and all the web resources are located in the database, centralized database or a server. So then all the resources can be accessible by the connected users. But in case of a distributed system, resources may not be accessible. Sometimes they may have the access privileges. Some users are not given the access privilege. So resources are restricted. Resources may not be accessible by all the users. So here the resources mean it can be a storage capacity. It can be the data. It can be the bandwidth. It can be the computing power. It can be the throughput, anything. Software runs in a single process. If it is a centralized one, so they have the central system in one place, one locations, and they have a single system here. So the software runs like application software, operating system, anything or any kind of application software, which is running in the single process. I mean the the centralized server or centralized computer, the software is running. But in case of distributed, they have a system in various locations, autonomous locations. Software runs in concurrent process on different processes. So they have a separate processor to run their system. And separate processors are running this application and softwares. Assume that one in one location they may handle or they may access all the customer transaction. In one location they are keeping what do you call this finance related transaction. In one location they may keep all the customer queries and customer responses. In one location they may handle all the backup. So different location they are handling or they are processing different type of data or different type of computing processes. Single point of control. If it is a centralized system, you can easily control single point of control. So a central system easily can it can be easily controllable. Like they have a database, they have a system, they have a server, and it can be easily manageable, easily controllable. But in case of distributed system, it is located in various geographical locations, and different type of processors, different type of applications are running. So these all are connected. So multiple point of control. So they want to establish a control mechanism for location 1, distributed location 1, location 2, location 3, location 4. Likewise, for each separate autonomous location, they must implement or they must have a separate control mechanism. Single point of failure. So this is the major disadvantage in this centralized system. Single point of failure means if anything happened to this particular system, the entire system will be collapsed. Centralized one, because it is in one locations. It is in one locations. All the resources are in this particular centralized systems. So everything will be collapsed. Single point of failure. And in case of a distributed environment, multiple point of failure. It means so these systems, if anything happened to this distributed system, so they have separate locations. So since they are running on the separate locations, so their systems, multiple location system can also be get failure. Sometimes they are connecting, they are sharing their data, they are sharing this what do you call this storage. So if anything happened to one location, it will impact on other connected locations also. So multiple point of failure. Sometimes these distributed geographical distributed systems are connected with the headquarters. If there is any problem in headquarters, So all the sub office or a geographical office system will be collapsed because their central system is failure. So other connected systems are also get failure. So these are some of the disadvantages. What the idea? Hello? 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 Can you hear me?
Yes, sir.
Yes, sir.
Okay. Now we are going to discuss about how distributed systems work, and basically we are going to discuss the distributed systems functionalities, the important functionalities of distributed systems. Okay, I will wind up today's session by this level, and we will continue the remaining aspect in this distributed system and web services, and the remaining aspect in the following lectures. So with that, I'll conclude. Any problem? Anything do you want to clarify? Anything? So in this lecture, we looked at what is a large scale system and distributed systems. What is distributed system? Some example for this distributed system and the characteristics between these centralized and distributed systems. And the next class, we will discuss about how these distributed systems are working. In terms of, we are going to discuss some of the important functionalities of these distributed systems. Any doubt, any problem, anything? Hello? Hello? Hello?
Yes.
Any problem?
No, sir.
No, sir.
So then we will continue by next week.
Okay, sir.
Okay, see you then. Take care.
Okay, thank you, sir.